this evening's lesson is about graphs of nonlinear inequalities. We're going to be able to graph hopefully polynomial, absolute value, and radical inequalities in two variables and to solve linear absolute value inequalities in one variable. The process for graphing works the same way as graphing a straight linear inequality, where you draw the boundary line, you pick a test point, and you shade the correct side of the boundary line. The first step we do is to decide on the type of boundary line, or boundary curve in this case. We have four possibilities. We have greater than, less than, greater than or equal to, and less than or equal to. On the first two, greater than and less than, the boundary is not included in the solution. If the boundary is not included, we get a broken line on the curve. On the next situation, where it's greater than or equal to, less than or equal to, the or equal to part of that means the boundary is included, which means our boundary line will be solid. Let's take an example problem. We have y is greater than the absolute value of 2 times the quantity of x plus 3 minus 4. And let's take advantage of what we learned yesterday. First, from today, we know that because it's greater than, we know that the boundary is going to be broken because it is not included. From yesterday, we know that an absolute value graph is always in the shape of a V. Also, other things that we learned yesterday, we learned how the graph moves around on the coordinate plane, and because it's x plus 3, or the equivalent of x minus negative 3, we know that the graph is going to move 3 to the left, and because of the minus 4, it's going to move 4 down. That meant our vertex is going to be at negative 3, negative 4. Because this is an absolute value graph, I do want to get some points on either side of the vertex. So I'm going to pick points to the left of negative 3 and the right of negative 3 for my xy table. So the points I chose for my x values were negative 5, negative 4, negative 3, negative 2, and negative 1. Notice my vertex of negative 3 is right here in the middle. I chose some to the left, some to the right. I know that when x is negative 3, y is negative 4. As I substitute in the values for x, I can come up with when x is negative 2, y is negative 2. When x is negative 1, y is 0. When x is negative 4, y is negative 2. When x is negative 5, y is 0. So I graph these points. Negative 3, negative 4, my vertex. Negative 2, negative 2, negative 1, 0. Negative 4, negative 2, negative 5, 0. And I connect these points with a broken line. Now I need to check a test point. I need to decide which side of the graph to shade. I can choose any point that is not physically on the graph itself. The graph is this V shape, so I can pick 0, 0 as a test point. The reason I like 0, 0 is because it's easy to add with, easy to multiply with. I'm going to substitute that into the original inequality, which was y is greater than 2 times the absolute value of x plus 3 minus 4. I'm going to put 0 in for x and 0 in for y and see if I end up with a true or false statement. When I substitute in, I end up with 0 is greater than 2 times the absolute value of 3 minus 4. 0 is greater than 6 minus 4. 0 is greater than 2. This is not true, it's false. That means the portion of my coordinate plane where 0, 0 is false. That means it's false all the way around the outside of that V shape. That means it's true on the inside of my V shape. So I shade the inside. On the next page of your note sheet are 2 problems for you to practice. Pause the video and try the problems. Check your first problem, pause it, and then check your second. Check your second problem. This one is an interesting problem because of 2 things. One, there's what I might call a domain issue with a square root or radical problem. We can't take a square root of a negative number, which means the radicand has to be greater than or equal to 0. So I start with x plus 1 is greater than or equal to 0, so x has to be greater than or equal to negative 1. This means my graph can't go to the left of negative 1. It starts at negative 1. The other thing that's a little bit different about this one is when I solve a square root inequality, I always choose my test point under the curve. That way I guarantee it's in the domain of the graph, not just arbitrarily picking 0, 0. And then I test it to see if I shade under the curve or over the curve. The next thing we're going to work on is solving an absolute value inequality algebraically. This is just an inequality in one variable, and this is something that you did back in Algebra 1 and Algebra 2, so this is a review. The key things that are the most important is, first, to isolate the absolute value. This absolutely, positively must come first. If you don't do this first, you're going to get it wrong. Then you have to consider the absolute value. And because absolute value is distance from 0, you have to consider the distance to the left of 0 and the distance to the right of 0. Then you have to solve both cases and graph the solution. So let's start with the problem 3 plus x minus absolute value of x minus 4 is greater than 8. The first thing I need to do is I need to isolate that x minus 4, my absolute value portion. So I subtract 3 on both sides, and I end up with the absolute value of x minus 4 is greater than 5. What this means that x minus 4 is more than 5 units away from 0. Now let's look at that just part on a number line to start with. Here's 0 on my number line. Here's 5 units away from 0 to the right. Here's 5 units away from 0 to the left. This says x minus 4 is more than 5 units away from 0. So all of my numbers for x minus 4 have to be out here on this side of 5, to the right of 5. And all my numbers for x minus 4 have to be to the left of the negative 5. Let me make that a different color so it doesn't look like a part of the number line. If I know this, it can actually help me write my disjunction. In this case, I'm going to solve first the right side, which is x minus 4 is greater than 5. You can see that because my x minus 4s are to the right of the 5 on the number line. The other inequality that goes with this when I consider the left side of the number line is x minus 4 is less than negative 5. Notice that the inequality reverses. It started with greater than, and when I did the disjunction, I used less than and changed the sign to its opposite. Now I solve these 2 inequalities. When I add 4 to both sides, I get x is greater than 9, or adding 4 to both sides, I get x is less than negative 1. This is what my inequality should look like on a number line now. My final solution, on my number line, I'm going to have negative 1 on the left side. It is an open circle because it was a plain less than, not less than or equal to, and that side of the line is shaded to the left. On the right side of the line, it's going to start at 9, and it's going to go to the right. So this is what my number line graph would look like. Now, you can actually check this graphically on your calculator. One way to do it is to transform the inequalities so that one side equals 0. That's so that we can use the y equals function on your calculator. Graph what's there, and then shade the appropriate side. Where the axis is shaded is the solution. Now, transforming this problem so that I have 0 on one side, I would start by just subtracting x, and I would get 0 is less than the, excuse me, not subtracting x, subtracting 8. 0 is less than the absolute value of x minus 4 minus 5. Now, I change the 0 to y, so that's y is less than the absolute value of x minus 4 minus 5. I want to graph this on my calculator, so I'm going to bring up my calculator now. I'm going to go to y equals. I'm going to type in the absolute value, so to access that I go to Math, arrow right to Num, choose 1 for absolute value, then type in x minus 4, and now I have to arrow out of here. If you're on an older calculator, you have to close a parentheses there, and then minus 5. Now, the problem was y is less than, so I need to arrow all the way back to the left, and I need to pick the appropriate symbol in this far left blinking spot. So when I press enter, it changes it to a thicker line. When I press enter again, it gives me the top half of a little square. The top half is greater than. I wanted less than. I hit enter again, and it gives me the bottom half of the square, which is y is less than the absolute value of x minus 5. Now I look at my graph. I can see the V shape of the absolute value a little bit. It's kind of off the graph a little bit. So I might want to change my window so that I can see it better. Remember, my solution ended up less than -1 and greater than 9. So I'm going to change my window so that my x values are definitely less than -1. I think I just might make it -4. And then for my x min, my x max, I'm going to make probably about 13. That's bigger than 9. And I'm going to count by ones. And my y scale is fine. It doesn't matter about my, really doesn't matter about how low or how high I'm going, because I really just need to see the x-axis. So now I'm going to look at my graph. My graph has now been changed, and I can see the part of the x-axis that's shaded is this part to the left of -1 and the part to the right of +9. Exactly what I came up with when I solved it algebraically. Another way to check this on your calculator is to type it in exactly as you see it. I'm going to show you how to do that right now. I'm going to start at your clean y equals screen, and I'm going to type in the inequality exactly as it stands. So 3 plus math, arrow to num, 1 for absolute value, x minus 4, close your parentheses or arrow to the right to get out of your absolute value. Now to get the greater than sign, I push second and math, which is test, and greater than is choice 3, and then I type 8. And when I look at graph now, it actually gives me the equivalent of a number line graph for the function. This concludes tonight's lesson.